Hi. We're arguing for the proposition that the global food crisis will never, ever be solved by engineering. Our overall argument is that engineering solutions to increase food production will not suffice in halting the global food crisis. It needs to be coupled with both a global and national change in policy. The points we'll be discussing are the role of GMOs and food waste in solving food hunger, as well as how one's personal economic situation is linked closely to their ability to feed themselves. First, you may be wondering, what is a food crisis? Food crisis can be defined as a widespread scarcity of food in society, and causes of food shortages vary vastly from unfavorable weather to a global pandemic. Studies have shown that even a temporary loss of access to food has an irreversible effect on a child's learning, stature, and mortality. A report conducted by the World Food Programme found that at least 155 million people in 55 countries or territories were in crisis or above in 2020, meaning that 155 million people had inadequate energy or protein intake due to consumption gaps. That's an increase of 20 million people since 2019. Besides unpredictable factors influencing food production, such as the weather, the most present indication for a forthcoming food crisis is the exponential growth of global population. So the question of the hour is, how do we feed 9.7 billion people by 2050? The simple answer is to increase food production. Simply expanding arable farmland is not a sustainable method, as an exponential increase is needed to match the population growth. Focusing on options that don't include increasing agricultural land, engineering solutions through more efficient water usage or energy usage, and better food storage has helped to increase the overall food production, especially for small-scale farms. An example of this is drip irrigation, which has a water use efficiency of around 95% compared to the 75% of conventional sprinkler systems. Other technologies include genetically modified organisms, GMOs, as well as vertical farming. GM foods are produced to have a higher resistance to pests and diseases, which would reduce production cost as well as increasing the yield while maintaining a high nutritional value. In 2015, 10% of farmland was growing GM foods. This alone shows that there's a huge possibility for increasing quality and quantity of food at a lower price through switching to GM foods. However, this change will most likely not be seen, not because of the engineering applications, but rather due to the public's view of GM foods. The US, Brazil, and Argentina make up 70% of the world's GMOs, while in Europe and Asia, GMOs are either outright banned or have a high regulation surrounding them. Even if they were allowed, the stigma held by the public that GMOs are dangerous and unnatural would still persist. In New Zealand, no fresh GM vegetables, fruit, or meat can be sold, and processed food containing GM ingredients must be labelled. A survey of 9,000 New Zealanders in 2019 had only 66% of people say that GM foods were safe to eat, and almost 30% said they shouldn't be sold at all. So although GM foods are a great option to increase food yield and lower production costs, the difficulty lies in changing the governmental policies and public perception surrounding GMOs.
A better solution is addressing global and national policies surrounding the food crisis through the lens of political resolve, not simply technological fixes. These include changing consumption patterns and addressing hunger as a symptom of one's financial situation. Beginning with consumption patterns and food waste in developed countries, shops and restaurants offer all-you-can-eat and buy-one get-one deals, which encourage people to potentially buy more than what they can eat. In terms of potential food waste, producing just 1 kg of beef can use up to 15,000 litres of fresh water. 1 kg of sheep can use up to 10,000 litres of fresh water, and 1 kg of pork using up to 7,000 litres. A study showed that out of 107 people being interviewed in a buffet restaurant, on average there were 45.8 grams of food per plate wasted, with each person using up an average of 5 plates. This equates to 42.5 kilograms of food being wasted just from those people being interviewed. and this only takes into account water waste. What about land for planting, fuel for harvesting, and transport vehicles? According to the UN Food and Agricultural Organization, 1.3 billion tons of food, 30% of the global production, is wasted annually, enough to feed 2 billion people. Certain aspects where food waste occurs in the supply chain, such as food storage and preservation, can be addressed with engineering solutions. However, in most cases, like fruit and vegetables, most of the waste comes from the sorting and grading process, which discards those that don't meet the quality standards set out by retailers and consumers, like those which have cosmetic imperfections. Food waste factors such as overproduction and high consumer standards are only solved through a change in our consumption patterns, and engineering solutions will have a limited impact on food waste. As for the economic situation, we will take COVID-19 as an example. Due to lockdown, markets for selling crops have been closed. This leads to food waste such as dumping produce, resulting in problems with the supply chain. Many meat industry plants have also been shut down due to lockdown, causing even more shortage of food and therefore leading to higher food prices and ultimately causing a global food crisis. Due to this shortage, according to the World Bank, 96 million people were driven towards food insecurities. A study shows that due to COVID-19, food prices have risen by 24 to 44% for basic items such as green vegetables across many countries. Those most heavily impacted are the ones in a vulnerable economic situation. As an engineer, there is no technology that can combat these markets closing. The only fix is to apply some policies to aid these businesses to prevent them from closing.
In conclusion, the global food crisis will never be solved by engineers. Engineers can help the food production process and make it more efficient and cost-effective, but these methods won't provide a sustainable long-term solution. It needs to be combined with shifts in global and national policies, changing the way that people view food and recognizing hunger as a product of poverty and one's economic situation. All these factors combined will help to solve the question of how we feed 9.7 billion people by 2050. Thank you.